Okay, so we thought that it maybe would be helpful to go through the pre-lab with you guys. So we're using a mock set of data before you actually perform this or virtually perform it. So this is the data that we're going to play with. For the partial pressure, it's just wanting you to look at the table that was attached to this handout. And at 22 degrees Celsius, this is the table that we're talking about. We would end up seeing a partial pressure of 19.8, and that's in millimeters of mercury. So I'm going to write that in here. All right, so then going through all this, and I'm going to see if I can get it to actually fit in these tables so you can see where the numbers actually come from. So if we first, and remember what we're actually doing here. So this is going to be a little different. We are going to be creating an experimental value for R. So we're going to have all the variables this time except for R, which, we're not used to that. Normally we're used to always knowing R and then solving for something else. But we're going to compare what this data would tell us the value is for R and then to what we know it is based off of our reference sheet, and it's a constant. And then that's going to help us come up with a percent error here. So for moles of mercury, we're simply just doing a conversion here of 0.0277 grams. And I'm going to use molar mass. I don't know why I said mercury, you guys, sorry. Molar mass for magnesium, which is 24.31 grams in 1 mole. And then I want to convert that. Okay, so when we do that, I get 0.001139. And I'm not going to worry about significant figures. At this point, it looks like we're going to end up having 3 sig figs eventually. And that's moles of magnesium. And then like this says here, we've converted, this also equals the moles of hydrogen gas based on the balanced equation because it's a 1-to-1 ratio. So we can use that number as well. And we're going to use that number whenever we go into PivNerd. So our temperature calculation, remember we have to change everything into Kelvin. So we're going to add 273 to this to get a Kelvin number. And I get 295 Kelvin. And then the partial pressure caused by hydrogen gas alone. So the total pressure is this 765 millimeters of mercury. That's going to be equal to the pressure of hydrogen, which is what we're solving for, plus the pressure of the water vapor, and that's why we found this number before. So plus 19.8. And let's see what we end up getting here. Looks like 745.2. Again, I understand that significant figures would stop at that ones place, but I'm just going to carry it through and worry about all that at the end. The volume of the hydrogen gas we have is 28.41, but just for the PivNerd equation to work, we're going to have to change that milliliter into liter. You just underline these so you know what we're focused on there. So we end up with converting this. And we get 0.02841 liters. Okay, so then for the experimental value of R, so we have all of the variables here. We're going to plug this in and see based off of these numbers, what would R say that it should be. So my pressure, now remember we really need to change this one more Oh, it says here, convert into atmospheres. And so remember to do that. It actually says concert to atmospheres. I like that better. Let's do that. All right, so to do that, we got to take that 745.2 millimeters and divide it by 760 to get an ATM measurement. I'm running out of room, so I'm going to do this right over here. So 745.2, I'm dividing it by 760 because I've got to get into atmospheres for PivNert to work. And I end up with 0.98. And again, I'm going to go a few past this atmosphere. So now I have everything in the units that I need it to be in. I have moles, I have Kelvin, I now have atmospheres, and then I have liters. So my pressure, 0.9805 times my liter amount, 0.02841 times my mole amount, 0.001139. I'm solving for R. This is weird this time. Times 295. So when we do that, let's see what we end up as an R value. And I'm getting 0.0829. I'm going to go a few past. So 2903. Again, significant figures here. Boy, quick look. Looks like we have 3 sig figs that we can work with here. And what we're being limited by is this 295. Okay, so then this will become 0.0829, and that's our value for R. That's our experimental value for R. So then to find the percent error, the true value, we're going to go off of our reference sheet, 0.08206 minus 0.0829, and we're going to divide that by 0.08206, and then this whole thing is going to get multiplied by 100%. Okay, so that's what we end up with here. So 0.08206 minus 0.0829 divided by 0.08206, and then times 100. And I'm just going to plug that in one more time to make sure that I have this right. And I'm getting, and remember it's the absolute value of all of this, so I'm getting a 1.02% error for this. Okay, so I'm going to go back and box these answers. This would be my R value. Okay. Right here is the volume that I worked with. I had this as my original pressure, but I had to convert it over here. This is the number that I actually used in the equation. My Kelvin. And then this is the moles that I worked with. We're hoping that that helps. If what we're going to want you to do is to just write these values in these boxes, and then you're doing all your calculations on another sheet of paper that you're going to take a picture of, and you'll end up putting right down here. Our hope is that this gives you enough guidance to understand how to work with the numbers from the lab. if you still have questions, it's your responsibility to get on to online conferencing next week. So remember, Miss Mercus, 10 to 11 Monday and Wednesday. I'm 10 to 11 Tuesday and Thursday. And that should give you plenty of chances to be able to ask us questions for guidance. So really take advantage of those online conferencing times. Okay, take care. Hope it helps.